Hello everyone. After learning the principles and working process of reverse osmosis, let's learn the operating parameters of it. First, the process flow of reverse osmosis. The basic process flow is single pass, as shown in the picture. There are two operating modes. One is a single process and the other is a cyclic process. In the single process, the influent passes through the reverse osmosis unit for one time before the desalinated water and concentrate are discharged. This mode has a low recovery rate of water and is less used in industry. In the cyclic process, part of the concentrate returns to the untreated water tank to get treated again, so that the recovery rate of water is increased, but the effluent quality will be reduced gradually as the concentrate is concentrated. Generally, the effluent of single-pass reverse osmosis could not satisfy the quality requirements for life and production usage. Besides, the large amount of concentrate discharge leads to a low water recovery rate. To improve the effluent quality and reduce the concentrate amount, multi-pass, multi-stage process is often used in reverse osmosis. In such process, the two terms pass and stage should be distinguished clearly. The addition of one pass is to further desalinate the effluent to increase the desalination efficiency, while the addition of one stage is to further concentrate the concentrated water to improve the water recovery rate. This is a one-pass, three-stage process. We can see that the concentrate is treated through three stages to improve the water recovery. This is a two-pass, one-stage process. The effluent of the first pass gets further desalinated in the second pass and the effluent quality is improved. Next, let's look at some basic parameters of reverse osmosis, including water flux, which directly influences the time efficiency for water production, operating pressure, which determines the energy consumption of reverse osmosis, desalination efficiency determining the effluent quality, and water recovery rate determining the pure water production. Let's begin with the water flux. It depends on the pressure difference between both sides of the reverse osmosis membrane and osmotic pressure. Water flux occurs only when the pressure difference is larger than the osmotic pressure, and the larger the pressure difference is, the higher the flux is. In addition, water flux varies with the permeability coefficient of water, Kw. It is affected by properties of the membrane material. The larger Kw is, the higher the water flux will be. Then, the desalination efficiency. It can be calculated by this formula. It reflects the rejection effect of reverse osmosis membrane to solutes in water. For reverse osmosis process with cycled concentrate, according to the mass balance, the average concentration of the inlet side of the membrane can be calculated by this formula. Ca is the average value of concentrations in concentrate and influent used as the salt concentration on the inlet side. Thus, Cf could be replaced by Ca in the formula for calculation of desalination efficiency. Next, the operating pressure. It's an essential parameter affecting the performance of reverse osmosis. Higher operating pressure results in larger driving force and higher water flux. It influences the desalination efficiency as well. Let's have an analysis about it. Besides water flux, there's a solute flux Js in reverse osmosis. It equals the product of permeability coefficient of the solute and concentration difference between the two sides of the membrane. Besides, it's also the product of water flux and concentration of desalinated water. Given certain conditions, the water flux is proportional to the pressure difference. The solute flux is proportional to the concentration difference since it's mainly related to the molecular diffusion. Thus, increasing the operating pressure could increase the water flux and reduce the solute concentration of desalinated water, increase the desalination efficiency. The figure shows a change of water flux and desalination efficiency with the operating pressure. Besides, the operating pressure affects the energy consumption. Higher pressure consumes more energy. Last, the water recovery rate, which is the ratio of flow rates of desalinated water to influent. The increase of water recovery rate can reduce both the concentrate amount and the energy consumption. However, excessive recovery rate would cause the increase of osmotic pressure of concentrate, increasing the reverse osmosis resistance and the scaling risks. Therefore, it should be kept within a proper range. Reverse osmosis is generally applied in desalination of seawater and brackish water, whose salt concentration is more than 30 grams per liter and from 0.2 to 10 grams per liter respectively. This table is a reference of the basic parameters of reverse osmosis, including water flux, operating pressure, desalination efficiency, and water recovery rate for both cases. That's all about reverse osmosis. In next section, we'll learn new membrane separation processes, ultrafiltration and microfiltration.